everyone, and welcome back to the Water Online Show, powered by Water Online, the leading online destination for the water and wastewater market. Today's episode, we are going to be focusing on a critical but often overlooked part of treatment operation, which is media vessel design. With granular activated carbon, ion exchange resin, or other filter media reaches the end of its life, utilities face a big challenge: how to safely and efficiently remove, replace, and restart. Vessel design is absolutely key to that process. From manway placement to underdrain engineering to backwash systems, confined space safety, and even site access for trucks and cranes, every design decision impacts cost, downtime, and worker safety. But the story doesn't stop there. We're also seeing new innovations that are reshaping the way that we think about media. At the forefront is our friends at Calgon Carbon. And here to tell us more about what they're up to is our friend, Mr. Ben Goecke, the Senior Technical Sales Representative for Calgon Carbon. Ben, welcome to the Water Online Show.
Yeah, thanks for having me, Travis. I appreciate it. It's good to be here. I think you summed it up really well. We're here to talk about optimize the design of their GAC or ion exchange treatment systems by the equipment. You know, equipment is often can be overlooked during the design phase. Folks always understand the importance of selecting the correct media, but we like to make sure folks understand that that's not the whole picture, and vessels play a huge role in the performance of these systems.
Well, it goes without saying that the process is only as good as the equipment. So if we're talking about the equipment specifically, I want us to draw a distinction here, and you could probably help us with this better than anybody. What are the different vessel underdrain designs for GAC or ion exchange vessels? Could you be able to elaborate on what those differences are?
Yeah, that's a good place to start. So really the number of designs out there, it's too many to count, but by far there are three that are the most common for these applications. The first one is the internal cone underdrain, and that's you can sort of picture it as like an ice cream cone, kind of an inverted cone with a bunch of septa nozzles. I'll use those terms interchangeably, septa nozzles.
That's okay. I won't judge.
Yeah.
Go ahead.
And so that's the first one. The second is the external ring header. So you can picture that. It's just basically 8 holes punched in the bottom of the lower shell of the vessel with a collection ring pipe below it. And then the third is going to be the header lateral system. So that's you've got a common influent coming in the lower side shell of the vessel, and then it's got these laterals, or you can kind of picture them as spider legs or octopus tentacles that spread out over the bottom to collect the water. And all these underdrains basically are attempting to accomplish the same thing, which is keep the media in the vessel and let the water go through.
So those are the three main ways to kind of map it out. So would you be able to give us a quick summary of the pros and cons of each of them?
Yeah, absolutely. It is true. Each has their own benefits and drawbacks. The internal cone is I would say the biggest benefit of the internal cone is that it has more nozzles than any of the other designs. Okay. It has about 1 per square foot of cross-sectional area.
That's a lot.
So you can imagine that a lot of nozzles means a lot of flow paths, right? A lot of potential paths for the water to take. That means good distribution over the bed of the media, which means good media utilization. Figure you're going to be using up this media, so you don't want to have it look like it's all used up before it actually is all used up. And that's where some of these other designs can kind of fall short. The external ring header, I mentioned it has 8 septa. So that's 1 per about 14 square feet of cross-sectional area. So that means fewer flow paths, right? The water is going to tend to prefer going towards those 8 nozzles. What you'll find is that some of that media around the lower perimeter outside of the nozzles and then down right in the center gets unutilized, right? And we actually have measured this with computational fluid dynamic modeling, and it seems upwards of about maybe 20% of the media in that design just doesn't get used.
Okay.
So, you know, this media is not cheap, and you don't want to change it out till it's fully expended. So I think that's one of the main drawbacks of that design. The header lateral is kind of a mix between the two, right? So you've got this common header coming in, and you've got these laterals. Well, those laterals closest to that common header are actually going to see more flow than those at the far end, because there's going to be more suction, shall we say, closer to that common header. So you're going to see uneven media utilization in that design, but it's not, it doesn't have the same profile as with the external ring header.
Makes sense.
Now, so I mentioned drawbacks and benefits in terms of flow. One of the benefits of those other two designs, the external ring and the header lateral, is that they can be made shorter. So if you're in a situation where height is a major concern, because those under drains are underneath, they do tend to, you can save a 1.5 to 2 feet, but in general, the trade-off in terms of just the utilization of the media is pretty significant. So really most of the time, it's going to be the cone that's going to best serve the customer. Now there is one other thing that needs to be considered, and that is the serviceability. Once this media is spent, it needs to be removed from the vessel.
Sure.
The cone has a slope of 30 to 45 degrees, depending on the diameter of the vessel. And because the angle of repose of GAC, not to get too technical here, is about 23 degrees.
Right. Yeah. Okay. 23 degrees.
It's more than that. So when you slurry the GAC out, it will flow down the sides of that cone and out the drain at the bottom. The other two have a dished bottom, which isn't nearly as sloped, at least not in the center. So you end up with remaining carbon or media resin in the bottom, and that can mean you've got to open the vessel to hose it out or rinse it out, and that introduces a whole host of challenges like additional time, potential for contamination, things like that. So the two main things to consider are media utilization and serviceability. How do you get that spent out?
Well, I know that utilities often are faced with trying to save on three things, because we've never come across an overfunded utility municipality ever. In all of our years here at Water Online and doing the Water Online show, that's never happened. But so typically the levers to pull are saving time, money, and energy. So as they go through the evaluation process, it's important that you pointed out a lot of the things that you did, even at a technical level, so they can think through, all right, how is this going to save me time, money, or energy? So there's a lot of good detail in there. Stay ahead of the curve with Water Online, your trusted source for the latest news, insights, and solutions in the water and wastewater industry. As a reader, you'll access exclusive expert interviews, in-depth technical articles, and practical resources to help you tackle today's toughest water challenges. Join the community shaping the future of water and wastewater at wateronline.com. Some say internal cones are tougher to maintain than external header systems. So I want to dig a little deeper on that. Can you talk us through those concerns and how specific vessel design makes servicing and upkeep easier, better, more efficient, all of those things?
Yeah, that's a good question. And I've certainly heard that claim before. I think if you really think about it, it tends to be the opposite, and I'll tell you why. Yeah. That claim tends to focus on the difficulty of lining the internals of these vessels, right? The cone has more internals, so more care is needed to properly line it. But as long as your welds are smooth and you're following the lining manufacturer's application instructions, you're really not going to see an issue. If you want to talk about serviceability, the main thing that is going to affect the utility year over year over year is changing out that media. Yeah. With an internal cone, you can change out actually 2 vessels in a single day. Pull the spent out.
That's good.
It's great,
quick, man.
and
awesome.
you should watch these guys do it. It's slick. Spent out, fresh in, and they're moving on to the next one.
It's almost like a pit stop in NASCAR, right?
Where exactly.
Goes in
and our guys are just such pros, man. They've been doing this for decades. So
Calgon Carbon has a reputation for that. That it's absolute pros. They know exactly what they're doing. But I'm sorry to interrupt, but go ahead.
Not at all. But even our pros have limitations in procedurally when you've got a bottom that is not sloped enough
Mhm.
You can't get all the media out by a slurry. It's just not going to happen.
Right.
So in order to ensure you've got complete removal, you're going to have to pop open that manway, rinse it out. Once you've opened the manway, you need to disinfect it because you might have introduced contamination. So that
Right.
adds time and cost. You got to pull back tees. You got to button it back up. And then the guys are going to have to come out once you're all clear to put the media in. So now you're talking multiple days, multiple mobilizations, multiple additional trucks, and that is costly. So when you're talking about serviceability, these vessels are designed to last for decades,
Okay.
and premature failure is pretty unheard of. So concerns about corrosion and improper lining, while that's very legitimate and needs to be taken seriously, it's
Sure.
quite rare. In reality, you're going to be changing out the media uh, tens and tens of times over the life of the vessels. And if you can do that quickly, you're going to have less downtime, you're going to save money, and it's just going to be easier for the utility.
So you had one of the things you had just mentioned in addition to time is it saves money. So I wanted to talk about cost and logistics here. So what are the costs and logistics involved in removing spent media from the vessels themselves? And even take it a step further, what often gets missed when having these conversations?
Yeah. Well, so just to talk you through the process a little bit, when the media is spent and you got to change it out, we bring out a trailer.
Okay.
These trailers have multiple compartments, so we hook up one of the empty compartments to the vessel. We fill the vessel. The vessel's usually already full of water. We pressurize it, and then we open the valves, and the media just slurries into the truck. Right? It's pretty
Mhm.
slick. Um, and so, assuming you get all the media out, then you just hook up the other compartment to the fill line. You open the valve, and you pressurize the trailer, open the valve, and it flows right into the vessel. So now you've only used one truck, and you've mobilized one guy. It's usually one guy, sometimes a couple of guys, but
Okay.
and then you're done. In the event that it doesn't happen, you bring out the empty truck to remove the spent, and then that truck has to leave the site because you've got to open the vessels, got to go through the disinfection process, which is going
Sure.
to take several days. You can't leave the truck there for several days. So
Right.
when it does come time to do the fill, you got to bring a new truck. The crew's got to come back out to the site, and we're talking, 6, 8, 10 grand per
Right.
service
Yeah.
just for those extra costs. So
Mhm.
it really does it really does matter.
I mean, I don't know, again, too many operations that have just an extra eight to $10,000 lying around, for that to be able to absorb that extra cost. So the fact that you monetized it and broke it down like that is certainly helpful, and it gives a lot more narrative to what it is we're talking about all of the benefits of the topic that's on the table for today. Let's
Yeah.
bring a human element into it. Let's stop talking about money for just like for a second, money or time. Let's talk human here. So, what's the experience like for customers working with Calgon Carbon from a vessel implementation to a long-term performance standpoint? And then we can get into maybe some specifics about any stories or feedback that stands out. But talk to us about the experience.
Yeah, I mean, we've got the A team at Calgon Carbon, from sales to applications engineering to marketing to field service. And out of all those groups, I think our field service group deserves the most credit. Most of those guys, I think I mentioned, have been with Calgon Carbon for decades,
Right.
and they are absolute pros. They're traveling all over the country. They're running into all kinds of unforeseen issues that they got to solve on the fly. And most of these guys know our customers by name. They see them once a year when they're doing a change out, or every other year.
Right.
And so we've really got terrific, personal relationships with these customers, and they know their field service guy by name, by face, and the process. I mean, every step of the way that the customer talks to their salesperson. If they have a problem, they talk to they have an applications engineer, a dedicated applications engineer for them. And when it comes time to do the change out, they've got their field service team that they know and are comfortable with, and they know is going to do the job right. So it really is a customer focused operation from start to finish.
What would be the first sign indicator for if a customer needed help from Calgon Carbon? Like what kind of problems would they be encountering, and to what intensity, and what would be some of the first sign indicators for that?
Oh, well, it's all kinds of stuff. I think at the basic level, you put the media in the vessel and then you track how the vessel is performing. And customers often report back to us about, hey, we have these in-bed sample taps in these vessels so that we can measure the mass transfer zone, see how far down the vessel it's gone so that we can sort of help try to predict when they're going to need service. And they'll report to us how things are looking on those sample taps. And
Okay.
when it comes time to do a change out, they call and we get it scheduled. And I would say for a majority of customers, other than regular check-ins and touching base, that is how they like it. They want to know that we're going to be there when they need them. But sometimes there's a problem. Sometimes, hey, I got some weird head loss buildup issues, or I went with this other supplier's carbon and now it's not working and I need help to get this figured out. And
Right.
whatever the problem is, we're going to be there to work with them. And in some cases, even if it's not our carbon, we're the guys they call because we're the ones they know are going to be able to solve it.
Well, certainly a lot of experience in the area, and there's in the area of what we're talking about here, and there's no doubt that Calgon Carbon has made a name for itself as a go-to place if you need answers and you need help. Ben Goecke, thank you very much for joining us here today on the Water Online Show. In addition to finding information on Calgon Carbon on Water Online, where else can they find a way to contact you or to learn more about Calgon Carbon?
Yeah, our website is terrific. nomorepfas.com is a great place to go to get in touch with us and to learn more about our products and services. You can always call me or any one of my colleagues directly, and we'd be happy to help you.
There you go. It's certainly front of mind of a lot of our listeners and the water industry as a whole. So I'm sure that the information that we talked about today is going to be very helpful. And if you need more information, you can go ahead and follow the trail that Ben had just laid out for you, or find more information on Water Online. Ben, thanks for joining us here today. Yeah, go ahead.
Keep an eye out for us at WEFTEC this year. We'll be there. We'll have a presence, and we're looking forward to meeting you if you're going to be there.
Well, I will say Calgon Carbon does attend ACE and WebTech, the two of the bigger shows here in the United States every single year. So certainly you're able to find their presence there. They're not hard to find, believe me. I've been there. Big presence there. Everybody kind of knows where to find them. For everybody listening, we want to thank you for spending your time here with us. We appreciate it. We hope you learned a little something here. I'm sure you did, and we can't wait to see you next time.
Been a pleasure.